Hello friends, myself Envi Lahamge, Assistant Professor, Department of Computer Science, MVP Samaj, Nasik.
In this example, we will try to solve two DFAs which are over 0 and 1. First is what? You have to design DFA like all strings contain at least two zeros, means at least having a meaning behind it as you can accept these strings having many combinations of 0, 1, but whole string contain at least two zeros. It can contain many zeros over 0, 1 means it can take zeros more than twos also, but minimum condition is what? You have to design this DFA for all those strings which having at least means minimum two zeros, maximum can be many. So like our usual mechanism, start with state Q0. Design these for having to accept two zeros, means at least two zeros. It can be many 0 and 1 there. For 1, bypass this to the same condition. Remember that the problem which we had seen in the last lecture, that is, or last video, that is at most. At most means maximum. Consider or remember in mind that at least means minimum and at most having the meaning as a maximum. So take one example of a string like 1 0 0 1 0 0 1 0 0 and one like 1 1 1 1 0. Okay. First is the correct string, second is the wrong string. Tally this with our machine. If 1 comes, then stop here. If 0 comes, go to the next. If 0 comes, go to the next. And for remaining all 0 and 1s means here you have satisfied your minimum condition for that string designing, that is minimum two zeros condition you have achieved. Then remaining whatever be the input would be accepted by your machine. So this is the correct machine. Now we will try to pass the wrong string from our machine. That is, it is having only 1 times 0. So when 1 comes, we will reach here. If next one, we will stop here for these. Also we stop here only for Q0. When 0 comes, you will reach at the Q1. But as you know, the mechanism behind the DFA is that only double circle or final states when you reach, then your string is accepted by that machine. But here, by tracing this string, you are coming to the state like Q1, which is not accepted state or not a final state. So this wrong input would not going to be processed in your DFA. So this is our correct machine. We will design its transition table, that is state input Q0, Q1, Q2, then Q0 on 0, Q0, Q1, Q0 on 1, Q0, again Q1 on 0, Q2 and Q1 on 1, Q1 itself, and for Q2 output stops here on itself. This is the mechanism behind all strings contain at least two zeros. Now you have to consider the next condition or the next string, that is you have to design this DFA for the condition like it contain at least or it contain at most two zeros, means you have to only accept maximum two zeros, not more than two. So I will give one suggestion while solving these type of examples, like when there is a one condition like at most, reverse the logic of at least. Means try to write DFA which was in the last or previous example. So what was the logic? Q0, then Q1 and then Q. What was the final state? That was the Q2. But when or while designing the conditions like at most means you can accept minimum also. So double circle the middle states also. And when the next unnecessary means 0 more than 2 appears in your machine, then bypass it to the dead state, that is known as the error state, and stop the remaining input here also. Means you have to only consider this for having the strings with condition like it contain only at most means maximum two zeros. 10 is also allowed, only 1 is also allowed, only 0 1 1 0 also allowed, but condition is that only you have to accept strings with two zeros exactly. Now we will draw the transition table. It is much easy. Put states here. As you know that all states in your diagram are double circle. So mark them as a final states. So Q0 on 0 becomes Q1 on 1 Q0. Table would also be same, but only having the one step or one state added here is Q error state, and for Q2 0 becomes Q error and 1 becomes Q2. Q error having Q error. This is all about the DFA for these strings contain at most two zeros in its whole life cycle.